So good morning. I'm going to tell you all about a project that we have going on here in Utqiagvik. It's a project that's funded by the National Science Foundation, and they're navigating the new Arctic program. We're still relatively early in the project. It's a 5-year project, and we are effectively conducting our second field season this summer as this symposium is going on. The title is Examining Interactions Between the Built and Natural Environments in an Arctic Community in Utqiagvik Sensor Array. So we have a really very interdisciplinary team in this project. The photos are just a subset of the folks who are involved, and you'll see that we have environmental scientists, we have architects whom you've met and you heard their presentation last night. We have data scientists, and the engineering component here is actually, at least the ones that are listed with the photos, are somewhat misleading. Those folks are in our engineering department, engineering school at the University of Virginia, but they're in the Department of Science, Society, and Technology. So they're actually social scientists in an engineering school who study how science is done. Other collaborators, Lars Nelson, who's local from Triben, Tom Douglas, and Taylor Sullivan from the Cold Regions Research and Engineering Laboratory. Chastity Oleman has been instrumental from North Slope Borough. UIC has been really important, obviously, for us to do our work here. Griffin Hagel from TNHA, and then also you heard from Aaron Cook. And we also have other collaborators, Georgina Davis and Chan Churun Safonsek from National Renewable Energy Laboratory, or CCHRC. Okay, so the project has 3 main goals. The first one is to understand how urban system components, buildings, and infrastructure interact with the surrounding air, ground conditions. The second project goal you heard about last night, if you were here, presented by Lena Cho and Matthew Joel, to generate environmental design analysis and guidelines to address sustainable development in Utqiagvik, hopefully, potentially as a model for other Arctic communities. And then the third one is an interesting one. I'll touch upon it later on in the presentation, to study how our research team, which includes our Utqiagvik partners, how we communicate across disciplines and cultures in order to produce knowledge that's useful for science for residents as well. Okay, so our objective was to cover sites in various areas around Utqiagvik, including commercial, residential, coastal, lagoons, and tundra. We implemented 4 main sites. We started this during the summer of 2022 for terrestrial meteorological sensing and ground surveys. And those 4 sites, you can see on the photo here, there's the TNHA 29 plex residential building, Samuel Simmons Memorial Hospital, the Busey Utilities Facility, which some of you went to yesterday, and then also out our tundra, which I guess is our control, out of the Barrow Environmental Observatory. So we have the 4 micrometeorology sites across Utqiagvik. 3 are in town, and 1 is out at in the tundra out of the BEO. So you'll see these micrometeorological stations in places where you might not normally see met stations. We're really trying to capture the of buildings and different aspects, different locations around buildings. So we're measuring air temperature, wind speed, wind direction, solar radiation, and ground moisture and ground temperature down to 90 centimeters, hoping to identify influences of infrastructure on local micrometeorological conditions, active layer dynamics, and then permafrost stability. So some of you may remember some studies that were done in the past here in Barrow by Ken Hinkle, Fritz Nelson, and Akleen, basically looking to see whether Barrow is a heat island or not. And they had an array of temperature sensors throughout the community. One of the Clean et al. 2012 study found that the summer was actually minimally a heat island. Showed a minimal heat island effect. There was, I think, one one of their land cover classes, one of their urban land cover classes was significantly warmer than the other urban land cover classes and the rural land cover classes. Looking in the winter, that's where the more substantive heat island effect was found. Hinkle and Nelson found a more prominent heat island effect, about 2 degrees Celsius warmer in the winter in the town of Utqiagvik than in the surrounding area. This urban heat island effect dissipated during windy days. So it appeared during calmer days and dissipated during windier days. So what we want to do is we want to look at a little bit more resolved meteorological data. So within site, a higher spatial and temporal resolution of the data. These are our 4 sites. So the focus is on aspect and various positional locations around buildings. So you can see, let's see if I can get this pointer going. You can see several sites around the TNHA complex and around the hospital as well. So I just took a snippet of the data that we're collecting. This is from summer of 2022. This is last summer, right when we first installed our equipment, and this is at the TNHA facility. So we're looking basically. I just cut the data for one group of sensors on the south side of the building, one on the north side of the building, and then compared those to the sensors that we have out in the tundra. This was an abnormally warm June last year for Utqiagvik. So you see some warmer temperatures here. So, but if we take the average over this summer period of record, which is a 3-month period of record, the south side of the building had about a degree C warmer was about a degree C warmer on average, and this is at 30 meter depth. So a degree C warmer on average than out in the tundra. The north side of the building was actually about 2 degrees C cooler on average at 30 centimeters than our control out in the tundra. If we look at the relationship between air temperature and ground temperature at these sites, you see that the relationship between air temperature and ground temperature was very similar between the tundra and the southern side of the TNHA building. But on the northern side of the TNHA building, there was the ground temperatures were quite a bit cooler, given the same air temperature. Some other things that we're doing. We're doing geophysical surveying. So this is Tom Douglas and Taylor Sullivan at CREL. We started some preliminary geophysical surveying in the summer of 2021. Most of us did not get up here because of COVID, but CREL was able to come at the end of the summer, right around the time of peak thaw. So and they'll be here in about a week or so, sampling again. So this will be our third of sampling. So they're doing ground penetrating radar, electrical resistivity tomography, active layer depth at all of our sites. So you see, we're trying to get quite a bit of coverage of GPR and some ERT at our core sites, the hospital, TNHA, UC, and they're also doing some additional measurements at the snow fences, the Cake Eater Road snow fence, Lower Madison Road snow fence, and then also out in the tundra as well. We're also doing repeat LiDAR of the facilities of focus. So this is Lauren Boucher, also at CREL. She's doing repeat LiDAR measurements of things on which we're focusing. Here's then you can do LiDAR differencing, and this is at the TNHA building, and with differencing in LiDAR, you can see potential movement. And this 2 years of differencing identified some movement at one section of the building. We also have an aquatic sensor array that's led by Claire Griffin, who's at the University of Southern Oregon right now, and Kenzie Nelson, a graduate student. We started doing our sampling in 2022. and they're here. Kenzie is here now, putting out additional samples, putting out additional sensors, looking at things like water temperature, conductivity, nutrient contents, ammonium nitrate, phosphorus. And by the end of this summer, we'll have 19 water bodies total that have sensors or have been done snapshot sampling. So very preliminary results, but not surprisingly, the water bodies within Utqiagvik have higher nutrient contents than the ones that are in the surrounding area, with regard to ammonium nitrate and phosphate. There's one exception, and that is this pond that is a road that is in close proximity to a road outside at the outskirts of town. Okay, thank you. That's perfect. We are starting to look into some particulate matter sampling. Philippe Rosado Murillo from University of Notre Dame is leading this with Mirella Shaban, one of our graduate students, and they're designing low cost, easy to use particulate matter sensors, open source, and so they're designing their own boards for particulate matter monitoring. It's really useful for fast prototyping of instruments, and it's also great as an education tool. And we thought this would be a nice something that would be great for community outreach as well. Just like a real snapshot, they were basically just testing it earlier this summer, but you can see the effects of the effect. This is during a single day, one sensor, so you can see these of road traffic on particulate matter, and then you could see the effects of the water truck passing, basically eliminating particulate matter. We have a really robust data pipeline. I'm hoping that the National Science Foundation will be very happy with this. We have a data pipeline that goes from the HoboLink software, pulling data from our data loggers, going to the UVA supercomputer where we can do all of our data analysis, and then the raw data will also be converted to NetCDF format and go to the NSF Arctic Data Center. This is part that I just want to highlight very quickly. We're hoping that we are co-producing knowledge with community members. We're doing our best, and I think we can continue to do better on that. Getting back to those engineers, the social scientists from the engineering department at UVA, somebody said earlier that they were a guinea pig. We're guinea pigs. I'm a subject in my own project, so we're being studied as to how we work together and work with community members to do this science. And then working on some outreach. We did a KBRW morning show last summer. We've been working with two local students. They happen to be Lars Nelson's sons, but we're hoping to expand that program to other students. We did a STEM event with the Utqiagvik Boys and Girls Club. Chancellor Sofonsak did tours of the NRL building down in Fairbanks for UAF students and a professor from Utqiagvik College. And that's all. So it's a pretty broad project. We're trying to do a lot. And thank you very much for listening.